Hey everyone, welcome back to my YouTube channel. You are watching Build AI with Sandeep. So far, we have discussed about the two fixes of the vanishing gradient problem that was creating problem in training deep language models. So we understand about the optimizer fix. Then in my last video, we saw that the activation fix, how Galileo solved the vanishing gradient problem in language models in large number of transformer based language models. I'm saying language models. I'm not saying large language models because large word is yet to come in the picture. So today we are going to understand the super important fix that you will just be with me for a few minutes and you will be also thinking that this is the most important fix that can be made at that time. So the fix is pre versus post layer normalization. So actually, in original transformer research paper, the normalization was at wrong place. So let's discuss what problem arose and what was the fix. There are three main problems. The first one is weak gradient flow. Let's first understand what exactly the gradient is. If you don't remember, so the gradient is basically tells us the direction plus amount to change in model weights to reduce error. In simple word, gradient tells the model how to improve. Let's suppose, for example, we gave an input to the model, it predicted something, for example, 7, and actual is 10. So the error is 3. Model is wrong, it needs correction. So gradient tell, should we increase or decrease weight and by how much? So this is the role of gradient in model training. So when researchers increases the number of transformer layers, then what happened was the gradient in the early early layers was very weak, was become very less. So learning becomes very weak as it goes backward. The second problem was training instability. So when there was a training, the loss goes up and down randomly. It is not stable. So in the next slide you will see what I mean about training instability. And the third problem was that the layer normalization, the place of layer normalization was not suitable for deep models. It creates vanishing gradient problem, as this is exactly the same to the first point, weak gradient flow. So due to the weak gradient flow, our model suffer vanishing gradient problem and poor learning. So these three major problems was faced due to the wrong layer normalization place. Now let's see in details. So here is the architecture, and now you can what I am trying to make you understand the layer normalization, the place of layer normalization. So here we compute loss and we compute gradient, and y cap is a function of weights. It goes backward. So when this gradient goes backward, it has to pass through this layer normalization. So gradient, the original gradient information changed here. Okay. Similarly, at this place also, it has to pass through this layer normalization, and again the gradient information change. So what is happening here? Basically, we have, let's suppose if we have 50 layers. Okay. So at first gradient is 1. Then after layer normalization, it becomes zero point 0.8. Then again after it is 0.7, after 0.6. So it is passing through an early layer, the first layer, the first layer. This is first. I hope you are understanding. So these are 50 transformer layers, and at this layer, the gradient value becomes 0 due to this layer normalization, and this is creating problem. This creates problem that early layers was not there was no learning in the early layers. And the second point, the training instability, I was explaining. So ideally, when we train a neural network or any model, the training loss should goes like this. This is ideal scenario. But due to this layer normalization, the loss moves up and down, up and down, up and down. So model confused in this situation that where to go. what to improve, how to improve. So this is the bad example. So that is why this is called unstable training. And this is the ideal scenario of training loss, and loss decreases smoothly, like 1 to 0.8, the similar thing, zero point 0.7. So it is decreasing smoothly. So this is stable training that we need. Now let's discuss about the fix. What was the fix? So the fix is very simple, very relatable. It is pre-layer normalization. What was happening? Researchers, even this fix was given by the data science community. Okay, this fix given by the community, not by any big organization. And they experimented that why don't we place the layer normalization before sub-layer of transformer architecture. So key important thing here to note that I am saying sub-layer. Sub-layer of transformer is basically multi-layer perceptron or self-attack, multi-head attention block. So I am saying these two components of transformer is sublayer. Okay, so before layer normalization is applied to this output, residual plus sublayer. So we pass an input sublayer of x, and then we add residual, then we add the output of multi-head attention, and then we apply layer normalization. This was the output. But after the fix, what was the output? That we first apply the layer normalization, then we apply the multi-head attention or multi-layer perceptron or feed-forward network, and then we add the residual. So by doing this, our gradient, our gradient was safe, will become safe. So let's suppose gradient comes here. Okay. So due to this residual layer, our gradient goes to directly at this point. Gradient will take the two path. The first path is the shortcut path. Okay. And the second path is processing path. So in a way, our gradient is taking a shortcut, and due to this, the gradient flow will be like this, that in start gradient is 1, then in second transformer layer it is moving backward, and in second transformer layer then also it is 1, then also it is 1, and in the after passing 50 layers, in the last layer it is also 1. So gradient preserve itself by taking shortcut due to the residual connection. Okay, so this is the simple fix that made the training possible of deep language models. So yes, in this slide we can see without shortcut, gradient is getting weaker and weaker after early layers, at the early layers, because we are going backward. Okay, and with shortcuts our gradient preserves. Gradient gets a direct shortcut path, residual connections preserve signals, and less distortion during backpropagation. So this solves the all three problems. Gradient will not get weak training smoothly. There is no ups and downs in loss. And the third is deep neural network, deep transformer models training was possible because of this simple fix. We are not adding anything in the model. We are not introducing something new, but we just making a change in the original paper, original architecture, that we were just placing layer normalization at its right place. Okay, so this was the short explanation of this topic, and I already explained you the layer normalization in my layer normalization video. If you have not watched that video, then please do watch, and then you totally understand what is the goal, what is the role of layer normalization. Okay, and now so far what we have discussed, I want to give you a recap. So first we discussed, I gave you a glance of what is Gen AI and what are large language models. After that, I explained you, I take you to the 2016, where the transformer paper attention is all you need came. I explained each and every component of the transformer architecture. Then I explained you how GPT-1 trained in two phases, and the core idea was to predict next word only. In 2017, GPT-1 came. Then in 2018, Researchers understand that okay, the idea was very great, transformer architecture is very powerful. Why can't we just train a very deep language model where we use multiple transformer layers, but they face a problem of vanishing gradient problem. And to solve that problem, I explained you the three fixes. What was the fixes? The optimizer fix, the activation function fix, and this is the third fix that we discussed today, pre-layer normalization. Now we are in 2018. Now GPT-2 came in this year. And okay, so now let me show you the architecture of GPT-1 that came in 2017. GPT-1 architecture and GPT-2 architecture. What was the change that you will see here? So here you can see the GPT-1 architecture. So basically this is GPT-1 architecture, and you can see the layer normalization is it is post layer normalization. Okay, and layer normalization is after the sublayer, after the multi-head attention output and residual blow. And in GPT-2, let's see, here we can see that this is GPT-2 architecture, and layer normalization is pre-layer normalization. Here it is pre-layer normalization, and it is applied before mass self-attention, and after that a residual blow. Similarly in feed-forward network also. So this correction is made in GPT-2. And also one more line, we can say that we normalize first and then we process. It is better to normalize first. So this is it. And now in future, now in my next 3-4 videos, I will explain you what happened in around 2019 and 20. Now we solved one problem. We were able, researchers were able to train very deep networks. And after these three fixes, 50 layers of transformer work, 12 layers of transformer work, even 100 layers of transformer architecture works. 100 layers of transformer architecture works. So these three fixes were very powerful. Now what's next? Now these models are still language models. There is no large language model. So in 2019 and 2020, the researchers, the engineers at big company, OpenAI, Google, they train these deep networks on very, very large amount of data. And due to that reason, in 2020 or around 2019, people started calling these language models are large language models. The large words added to the language model. So when they are doing this, what problems comes and what were the fixes? So next 3-4 videos we will going to understand that thing. After that we will be ready to get our hands dirty on large language, on LLMs, on real LLMs. We will play, we will code on LLMs, we will see open source models and closed source models also. So it is going to be really fun in the next upcoming days. So be with me for next 3-4 videos. And that's it for today. If you like this video, then please do like, share and subscribe to my channel. I know you are watching my videos but did not subscribing. Please do subscribe. I really need this motivation so that in future I will come up with many great interesting topics. Thank you so much.